The process of delivering power from the generating station to the member's home is a challenging one. A complex system of interconnected wires and equipment must be in place, designed and constructed to work efficiently every hour of every day, and capable of being brought back online in a timely manner whenever nature or man temporarily interrupts its flow. During the next few minutes, we're going to trace the path of electricity from the Seminole generating station to our members' homes and businesses where it's used. We'll discuss the equipment Clay Electric uses to assure that power is reliable and available whenever our member reaches for that light switch. The bulk power supplied to our members is purchased through Seminole Electric Cooperative, a Tampa-based generation and transmission cooperative owned by Clay Electric and 8 other Florida-based electric cooperatives. Clay Electric's power comes from 2 principal sources. Most of the power used in our service area comes from 2 coal-fired, 600-megawatt, state-of-the-art environmental controlled generators at the Seminole Power Plant located in Palatka. The remainder of the electricity is purchased from other generation sources and fed into our distribution system. Electricity must be used the instant it is generated. As such, a maze of interconnected wires and components must exist and be maintained every step of the way, from the generator at the power plant right to the lights we all depend on in our homes or businesses every day. The power generated at the Seminole Generating Plant in Palatka leaves the facility at 23,000 volts, a level too low to economically transport long distances. Because of that, the power is routed through step-up transformers, where it's boosted to 230,000 volts. This higher voltage level ensures that the generated electricity can be sent long distances with minimum amount of electrical line loss. The generated electricity is then directed away from the power plant along high-voltage overhead lines called transmission lines. These heavy lines strung between tall towers eventually connect to the transmission lines of other electric utilities to form a grid. The electric grid is much like an interstate highway system, with its multitude of roads moving traffic onto and off of the main thoroughfare. It's these networks of roads, large and small, that allow us to travel to a particular destination. Similarly, Florida's utilities have developed a highway of interconnecting transmission lines to make certain that electricity being generated from both in-state and out-of-state sources is available and able to reach its ultimate destination, our members. The Florida transmission grid ensures the electric service can be quickly restored from another source if a power plant connected to the grid trips offline unexpectedly, and also allows some electric utilities connected to the grid to purchase power from other sources more economically than they can sometimes produce it. In Florida, transmission lines vary in size and carry power at levels ranging anywhere from 69,000 volts to 500,000 volts. Some transmission lines are routed through transmission substations, which are used to change the voltage level passing through the substation either up or down. Other transmission lines deliver the power directly to the distribution substations. Distribution substations are strategically located throughout Clay Electric's service territory and are used to reduce the voltage being fed into them at levels appropriate for the area the substation is serving. Their placement in the system is based on member density and the electric load requirements of that vicinity. Power from the distribution substations is next routed to the main distribution lines. Main distribution lines are often referred to as primary lines or feeder lines. These lines carry power at either 7,200 volts or 14,000 volts. Main distribution lines feed power to a variety of members, with a number of different electrical requirements. These members can be divided into 2 basic categories: primary service members and secondary service members. Primary service members are large industry and institutions which use electricity at high voltage levels. Quite often, primary service members use their own transformers to reduce the voltage being fed to them at levels they need to operate their businesses. Secondary service members are small commercial businesses and residential accounts which use power at lower voltage levels. The power these customers receive can be anywhere from 120 to 240 volts. Electricity is fed to them through nearby pole-mounted distribution transformers or pad-mounted transformers for underground service. These transformers reduce the voltage to a level that meets their specific needs. Electricity is then sent along a service drop, the line which stretches from the distribution transformer in the vicinity to the members. The service drop is the final link of the path which sends electricity from the power plant to the homes and businesses we serve. Now let's take a moment to discuss some of the equipment Clay Electric uses to assure that the power being generated, transmitted, and distributed gets to our members with minimum amount of service interruption. Seminole Power Plant generates clean, regulated 60-cycle electric power. But once that power leaves the plant, any number of things can happen to inhibit its ability to get to the members. Some of these deterrents are triggered by the sheer force of nature, others are caused by man, and still others are component failures, and so a series of protective devices are put in place along the system to guard and watch over the power being distributed. To assure that the generated electricity reaches its destination at an acceptable voltage, voltage regulators are placed in substations and on distribution circuits throughout the system. These regulators monitor variations in the voltage level being delivered and correct that voltage level up or down when necessary. We're all aware that factors beyond the control of Clay Electric Cooperative can periodically cause the electric current feeding homes and businesses to short circuit and trigger a power outage. Although cataclysmic problems have occasionally affected the generation and transmission portions of the system, the vast majority of power disruptions occur somewhere along the distribution system. The two most common causes of these power line short circuits, or faults as they're also called, are tree limbs coming in contact with nearby power lines and lightning strikes along the system. To minimize the effects of any power disruption, all electric utilities divide their distribution system up into sections, with each section overseen by a series of protective devices. Whether the devices are breakers, reclosers, or fuses, their main function is to isolate the faulted area from the rest of the system when a problem occurs, thus reducing the number of people affected by the fault, damage to equipment in the area of the fault, and the time it takes to locate and repair the problem. When lightning strikes in close proximity to a power line, it can trigger a voltage surge which travels along the distribution line until it's short-circuited by a lightning arrestor. These arrestors are interspersed throughout the system and are designed to conduct the lightning-induced surge harmlessly into the grounding rods driven deep into the soil below. Another common sight along both transmission lines and distribution lines are insulators. Insulators come in various sizes and shapes and are made of a non-conductive material. Insulators have one important job to do: to keep electricity flowing along the line and away from areas where it's not wanted. All of the protective devices just discussed are placed throughout the system along distribution lines, in the substations, and in any other area where trouble might potentially occur to assure that a reliable supply of power is available whenever and wherever it's needed. Today, electricity has quietly become our nation's most important energy resource. Having access to electricity today is as simple as reaching out and flipping a light switch. But as you've just seen, the path electricity takes from the power plant to the member is not quite so simple. Keeping the system functioning properly while also protecting it from problems caused by nature or man is an ongoing challenge Clay Electric faces every minute of every day of the year.